and solving problems. With 5 gas laws you're responsible to know. They all interrelate PV and T and or moles. The first 4 are really one and the same in the sense that if you know the combined gas law, then you can derive Boyle's law, which are occurring when we have constant temperatures. Charles' law occurs when we have constant pressures, and Gay-Lussac's when we have constant volumes. The problem states that a sample of gas at a temperature of 100 is contained in a 1.5 liter flask and a pressure of 2 atmospheres. First thing I like to do is draw a picture that describes the sample as particulate at the temperature, volume, and pressure given in the problem. Number 1 asks, if the flask is heated to 200 degrees, what will the resulting pressure be? And whose law? Well, we know it's a Boyle's law, a Gay-Lussac's law problem because it's constant volume. So we go to the Gay-Lussac's law and we plug in for P1, 2, T1, 373, P2 is what we're looking for, and the new temperature 473, and when we solve for P2 we should get 2.54 atmospheres. Problem number 2 says if you take the original sample and transfer it to a 500 milliliter flask, keeping the temperature constant, what's the new pressure? So we'll be looking for P2. We know it's a Boyle's law problem because we're at constant temperature. So we plug in our P1, which is again 2. Our V1 is 1.5 liters. And our P2 is what we're looking for. And our V2 is 500 milliliters or 0.5 liters, and when we solve that we get a P2 of 6 atmospheres. Number 3 says if the flask and contents are heated to 200, what will the resulting volume be if the pressure does not change? So at constant pressure, it's a Charles' law problem. Charles' law, we plug in. So we have a V1 of 1.5, a T1 of 373. We're heating it to 473, and we're solving for the new volume, and that will be 1.9 liters. Number 4 says if the gas is methane, how many moles and grams of that are in the original sample? And so we're using the ideal gas law, PV equals nRT now, and plugging in 2, the atmospheric pressure, 1.5, the volume in liters. We're looking for N. R's always given as that. And temperature of the sample, 373. And when we solve for N, we get 0.0979, and that's the moles. And since we're talking about methane with a formula weight of 16 grams per mole, we can convert the moles to grams, and that gives us 1.57 when we take 0.0979 times 16. Second part of number 4 says if we change to STP, what will the new volume become? So now again we're using PV equals nRT, and we're changing to STP, and you need to know that STP is 273 K and 1 atmosphere. And so our P is 1, our V is what we're looking for, N we just solved as 0.0979, R still 0.0821, and T at STP is 273. And when we solve for V, we get 2.19 liters. Number 5 and 6 will be coming in another video.